Hello children, good morning to all of you. This is physics class and we are going to start your second chapter, motion in one dimension. About motion you have many ideas. Now we will start from knowing that physical quantities. Have you remembered what is the physical quantity? Yes children, those quantities which we can measure. All those quantities which we can measure are called physical quantities. And we have to learn that how many categories are there for physical quantities. That means in how many categories the physical quantities have been classified. So children, there are two categories. One is scalar quantity and second vector quantity. And we will start our chapter from here. Okay. So first is the scalar quantity. What is the scalar quantity? Do you know? I hope you should know. But then also I am going to revise. See here. Those quantities which can be expressed by their magnitude only are called scalar quantities. Yes children, if the quantity can be expressed only by their magnitude. Suppose I give you one example. The length of this board is 1.25 meter. Here the meaning is clear. Length has been expressed in the term of magnitude. 1.25 meter is the magnitude of length of this board. One more example I am giving. Suppose the mass of this marker pen is 100 gram. The mass of this pen is 100 gram. So again mass is the quantity and it can be expressed only in the magnitude. Understood? So see the examples of the scalar quantity. Length, mass, time, distance, speed, density, work, energy, pressure, angle, frequency, amplitude, etc. All these are known as scalar quantities. Understood? Scalar quantities can be added, subtracted, multiplied or divided by simple algebraic method. Suppose that two lengths are there. One length is 2 meter and other length is 5 meter. Then we can add both the length by simple algebraic method. Means 2 plus 5 equal to 7 meter. Is this clear? All the scalar quantities can be added, subtracted, multiplied or divided by simple algebraic method. And all these are represented by English symbol, English letters. Like length is represented by L. Mass can be represented by small m or capital M, time by capital T. That means simply we can represent these by English alphabets. Okay. Now we are going to see vector quantities. See children, what are the vector quantities? Those quantities, those physical quantities which require both. What are the both? That is magnitude and direction to express it are called vector quantities. Understood children? Those quantities which require both magnitude and direction also. See the example. Suppose I say you displace one object 5 meter. Displace one object 5 meter. Is this statement giving you the clear idea? If an object is displaced, then where to displace? The question arises. It means the meaning is not clear. Now suppose if I say you displace the object 5 meter towards east. Now the meaning is clear. With the amount, the direction is also given. It means displacement is the vector quantity. See one more example. Suppose I ask you apply 10 Newton force. Now you will wait. Where to apply? In which direction to apply? It means if I say only to apply 10 Newton force, that means the meaning is not clear. Something is missing here. And that missing point is direction. Where to apply 10 Newton force? Now suppose I say you apply 10 Newton force on the board. Now the meaning is clear. That means vector quantities are those quantities which require both direction as well as magnitude. So force is also an example of vector quantities. Now see some more examples. Velocity, acceleration, force, torque, etc. Understood? We have studied scalar quantities and vector quantities. Now we are going to study the rest position and motion position. Okay? I am going to remove it. To write it, you can pause the video and you can note it down. Motion and rest. I think you have the idea about this also, but I am going to revise once again. What do you mean by motion? Definitely when one object changes its place from one place to another or one point to another, then that time the object is called in motion. And if the object is not changing its place, then that object is called in rest position. Okay? I hope it's very simple. An object is said to be in motion if it changes its position continuously or with respect to a reference point, okay, from its immediate surrounding. Okay, the object will be called in motion if it is changing its place. Suppose one object is here, after some time it reaches to another point, then we will say that the object is in motion. Okay, and just opposite, an object is said to be in rest position if it does not change its position. Okay, motion and rest both are related to each other, because scientist says that nothing in the universe is in the rest position. How? Our earth is moving around the sun. It means we are on the earth, so we are also moving with the earth. Our whole solar system is also moving. The galaxy in which our solar system is situated, that is also moving. That means according to physics, nothing is in the rest position at all. But the object is in motion or in rest position, that depends on the reference point. Suppose that you are sitting in a car and you are comparing yourself from the driver, then you both are in the rest position. But if the car is moving and you are looking out of the car, If the car is moving and you look out of the car, then you will see that all the objects are crossing you one by one. At that time you will say that you are in the motion. Understood? Your car is in motion, then also you and driver both are in rest position, because the distance between you both are not changing. Okay? Okay children? Now after this, we are going to learn next term, which is called distance and displacement. You will say, sir, what are you teaching so easy things? Yes children, all the things are easy what you will study in physics. See, distance. What is distance? Tell me. Say, sir, this is not live class, so how can I tell you just now? By the way, you can send the answer in comment. Here I am telling. Distance means the actual length of the path covered by a body. When an object is in motion, definitely it will cover some length, and that length of the path will be called distance. Okay? So what is distance? The actual length of the path covered by a moving body. Is called distance. Okay? The actual length of the path covered by a moving body is called distance. Its SI unit is meter. Okay, because it is a distance, it is a type of length, so its unit is meter. Next noted point is, it is a scalar quantity. Distance is a scalar quantity because it requires only magnitude to represent it. And if the body is moving, definitely it will cover some distance. It means it cannot be zero. Yes children, distance cannot be zero. Neither it can be negative. It cannot be negative. Is this clear everybody? These points I am telling so that when you compare distance and displacement, at that time these are the notable points. Since this is a scalar quantity, it does not require direction. It does not depend on path. Okay? Now we will see displacement. See, distance and displacement are the two different terms. Distance is the actual path of the length, but displacement is the shortest distance between initial and final position. See here. Displacement is the shortest distance between initial and final position. Now see, by example I am telling you. Suppose one object is start moving from here. Okay, see with diagram I am telling. Suppose one rectangle I am making. One object is starting from this point. Okay, first it goes from A to B and then B to C. Then what will be the distance? Distance will be AB plus BC, because the total distance covered by the body is this AB plus BC. But displacement is the distance between initial and final position. That means displacement is equal to AC. Are you watching? Displacement is AC because the shortest distance between AB and AC is displacement. Is this clear? And you are watching that displacement is depending upon the path. because we have to take the shortest distance, so a specified direction is also fixed. So you can say that displacement is the distance covered by the body in a specified direction. Is this clear? Is this clear or not? The difference between distance and displacement. Okay. Its SI unit is also meter. Its SI unit is meter. It is a vector quantity. It is a vector quantity, and it can be zero. It can be zero and it can be negative also, and it depends on the path. Now see how. One example. Suppose that one object is moving on a circular path. The object starts from P. The object starts from P and it is moving on the circular path and reaching to just opposite of P. Just opposite of P, it is reaching at point Q. In this case, what will be the distance and what will be the displacement? You can see that the object is moving on this path. So this is the semicircular. So here the distance will be half of 2 pi r, because 2 pi r is the complete circumference of the circle, the complete distance in one round. So in half round, pi r, this is the distance. And what will be the displacement? Displacement will be equal to this PQ, which is equal to diameter, means 2 times r. Are you watching the difference? Distance is the length of this curve path, which is equal to semi-perimeter, and displacement is the shortest distance between initial and final position, which is equal to the diameter. Okay. Now suppose that if the object is moving from P and after taking one complete round, again it reaches to the point P. In this situation, the total distance will be 2 pi r, because the object has completed one complete circle, one complete round. So total distance will be 2 pi r. And what will be displacement? Since initial and final position both are same, displacement will be 0. Understood? That is why displacement depends upon the path. It depends upon path. Is this clear? You have to write the difference between distance and displacement, that you have to learn. That is why I am telling you these points. With distance is the actual length of the path and displacement is the shortest distance between initial and final position. Distance is a scalar quantity, displacement is a vector quantity. Distance cannot be 0, displacement can be 0. Distance cannot be negative, displacement can be negative. Distance does not depend upon the path and displacement depends on the path. Is this clear? Okay, children. In this whole chapter, you have to study motion in one dimension. Are you understanding what is the meaning of it, motion in one dimension? Actually, when one object moves, if it is moving on a straight path, then that will be called motion in one dimension. It will be called motion in one dimension. And if the object is moving on a curve, then that type of motion is called motion in two dimension. And if the object is moving in air, if the object is moving in space, then that will be called motion in 3 dimensions. Is this clear? What do you mean by motion in one dimension? If the object is moving on a straight path, then that will be called one dimension motion. If the object is moving on a curve path, then that type of motion will be called motion in 2 dimension. And if the object is moving in a space, moving in air, then that type of motion will be motion in 3 dimension. Okay? Now the next term which we are going to study is speed and velocity. So first we will see speed. Many numericals you have done in mathematics based on speed. But what do you mean by speed? So children, speed is the distance covered by the body in unit time. Means speed is the ratio between distance and time. Okay. So what is the speed? The distance covered by a body in unit time is called the speed of the body. It means speed is equal to distance upon time. Okay, see this one. You can also say that the rate of change of distance, the rate of change of distance with respect to time is called speed. That also you can say, both are the definition. The distance in unit time, that definition is based on the numerical. Theoretically also you can say that distance covered in unit time is called speed. You can also say that speed is the ratio of distance and time. Okay. Now what will be the unit of speed? See this. Unit of speed will be unit of distance upon unit of time. Unit of distance is meter, unit of time is second. That means unit of speed is meter per second. Okay, and it is a scalar quantity. It is a scalar quantity. Speed is a scalar quantity. Okay, now we will study uniform speed. Uniform means same. Uniform speed means same speed. If the object speed is neither increasing nor decreasing, so that type of speed is called uniform speed. So how will you define it? See, if an object covers equal distances in equal intervals of time. If an object covers equal distances in equal intervals of time, then the speed of the object is called uniform speed. Understood? The speed is not changing. Speed is fixed, means that is uniform speed. Same distance in same time. Suppose 1 kilometer is traveled in 10 minutes, then again the next 1 kilometer is traveled in 10 minutes. Then that type of speed is called uniform speed. Okay? Then one will be the non-uniform speed also. It will be if an object covers unequal distances in equal intervals of time. In equal intervals of time. Then the speed of the body is called, speed of the object is called non-uniform speed. Understood? If speed is varying continuously, That is why it is called variable speed also. Variable means changing. Suppose you are driving the bike, sometimes you are driving with 40 speed of 40 km per hour. After some time you are driving with 50. That means there is variation in your speed. Then that speed will be called non-uniform speed. Is this clear? If the object covers unequal distances in equal intervals of time, then that type of is called non-uniform speed. And I hope you know what do you mean by average speed. Average speed is the ratio of total distance covered by the body to the total time taken of the journey. What is the average speed? The ratio of the total distance covered by the body to the total time taken for journey. Understood? So that is the average speed. Okay. Now I am going to remove it. You can pause the video and you can note down all these things. What is the formula for average speed? Average speed is equal to total distance upon total time. This is the formula for average speed. One more term is there that you have to study is the instantaneous speed. Instantaneous speed means the distance traveled in a very short interval of time. So you can say that it is the ratio of distance traveled in a very short interval of time. Okay, so you can say that formula for instantaneous speed is equal to the distance traveled in short time interval upon time taken. That is the instantaneous speed. That means when you measure the speed of a body, suppose a body is moving for 10 seconds and you want to measure the speed between 8 and 9 seconds, then that type of speed is known as instantaneous speed. Okay. Now next term which we are going to study is velocity. Okay. As we know that velocity is a vector quantity. So in place of distance we will use displacement. Otherwise you can say that the distance covered by a body in a specified direction. The distance covered by a body in a specified direction is called its velocity. Okay, that means the speed will be called velocity if with magnitude we know the direction also. in which direction the object is moving. If we know this point also, then that speed will be called velocity. So velocity will be displacement upon time. Okay, what is the formula for velocity? Displacement upon time, because displacement is the direction, displacement in a certified direction or specified direction. Okay, now unit of velocity is again, how will you find unit of displacement upon unit of time? That means meter per second. So you can say that unit of speed and velocity both are same. Okay, and velocity is a vector quantity. Velocity is a vector quantity. Okay, now we are going to study uniform velocity. Uniform speed, uniform velocity. You can take the help of that. How to define it? Uniform velocity, same distance in same interval of time in a specified direction, in a certain direction. That means you can say that the same displacement in same interval of time will be called the uniform velocity. See how to define it. If the object covers equal distances in equal intervals of time in a specified direction. If the object covers equal distances in equal intervals of time, then the velocity of the body, then the velocity of the object is called uniform velocity. Understood? Uniform velocity means same distance in same interval of time in a certain direction. And then what will be the non-uniform? Non-uniform velocity, if the object covers unequal distances in equal intervals of time in a specified direction, then the velocity of the object is called non-uniform velocity. Is this clear? If the unequal distances in equal intervals of time in a specified direction, then that type of velocity is called non-uniform velocity. Now pause the video and note down this. Okay children, now we are going to study average velocity. Children, average velocity is the ratio of displacement to the total time taken in the entire journey. Okay, Average velocity is equal to ratio of displacement to the total time taken. So this is the formula for average velocity. Now the last term of this section is acceleration. Acceleration is the rate of change of velocity. Yes children, when one object moves, then either its velocity increases or decreases. If the velocity is increasing of that object, then we say that the object is accelerated. Theoretically, the acceleration means the rate of change of velocity with respect to the time. Is this clear? Acceleration is equal to change in velocity upon time. It is denoted by small a. Acceleration is denoted by small a. And since it is a vector quantity, it will carry one arrow over it. Okay? And its unit is meter per second square. Understood? Acceleration unit is meter per second square because change in velocity. So velocity unit is meter per second and time unit is second. So when you solve it, you will get meter per second square. Okay. If the velocity is increasing, then that will be termed as the acceleration. Rate of change of velocity will be termed as acceleration. If velocity is decreasing, then that acceleration will be termed as retardation. Understood? Retardation and acceleration both are same. The difference is if velocity is increasing, then that will be, the change in velocity will be acceleration, and if the velocity of the object is decreasing, then the change in velocity will be called retardation. Now we will learn uniform acceleration. So children, the acceleration is said to be uniform when equal changes in velocity take place in equal intervals of time. Means, suppose that one object is moving. In 10 seconds, its velocity increases by 10 meter per second. The velocity increases by 10 meter per second. Again in the next second, its velocity increases by 10 meter per second. That means if you notice it, that at a certain interval, the change in velocity is also same, then that type of acceleration is called uniform acceleration. And if the change in velocity is not same in the same interval of time, then that will be termed as non-uniform acceleration. Okay, one more acceleration is there, which is called the acceleration due to gravity. Practically, we all have seen that if one object is thrown in upward direction, after attaining a certain height, it comes down. Why it happens? Because when one object is thrown in upward direction, its velocity decreases. It means acceleration is working there. Similarly, the object when it starts falling freely, then its velocity increases. It means acceleration is working there. From where this acceleration is coming? That acceleration is produced in that object because of the gravitational attraction. And that is why that acceleration is termed as acceleration due to gravity. And it is denoted by small g. Acceleration due to gravity is denoted by small g, and its unit is also meter per second square. Okay, so here this topic is over, children. In the next topic we will start solving the numerical based on these topics. Okay children, must prepare and learn each and everything. If anything is not understood to you, you can ask me in the next video. First I will solve those, and then after we will start the numericals. Okay, bye bye.